Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, now it's time to do the critical path method. We have gathered all the tools to go through the critical path method. Okay, we'll try to see find out the critical path. Okay, using the forward path and backward path, and we try to do all these things now here. So we have seen in the last video the steps required in this. So the first thing will be to have the activities and their immediate predecessors and their time estimates. This is our example now here, which is taken from the Globerson project management. Now in this diagram we have the activity, we have its predecessors, then we have the time estimates, and what we need to draw is a network diagram. The first thing what we'll do if we get an example problem in our exam is to draw the network diagram. Okay, so this is the network diagram, this is a simple one. So if you look here, we got A, B, and C. They have no predecessors. So when the nodes, when the activities have no predecessors, we can start them simultaneously. They can start from the beginning, that is start node, which is 0. Okay, and then we have the A, B, and C starting from the 0 and starting from the start, and their cost, that is 30, 15, and 25. We put the cost on the activity. This is called activity on node network. So what we do is we put up the time on the node. So that's called as an activity on node. Remember that thing. And we need to find, when we draw the diagram, we need to find the earliest start, latest start, earliest finish, latest finish. We'll see how to do them. Okay, so we're gonna have some 4 boxes on top of the each and every node and which has all these things. Now first let's draw the diagram. So how we are drawing the diagram is very simple. We have here A and B and C. They don't have any predecessors, so they can start from the start. So we have the A, then B and C, and the cost 30, 15, and 25 I put up on the node. That's called activity on node network. So 30, 15, and 25. After that, if I want to draw the D, I will see who is its predecessor, that is A. That means D will originate after A finishes. So A finishes here, and after that it goes to the D, which is a cost of 3. Okay, same with E, the predecessor is C. So starting from C, I can have the E, that's here, and cost is 7. Then F predecessor is B, for the F predecessor is B, so you can go from here. Okay, and the cost, whatever on the F is, that is 1, that should be here, which is missing. Oh, that's on top, here it is already. Okay, now after F is done, we got a G. The G, it has a 2 predecessors, D and F, but we don't have a parallel activities here, so we don't need dummy activities and all in this example. It's a very simple example where we don't have a dummy activity because G starts from D and F, but they are 2 different nodes, and from D also, from the F also, and the cost of it is 5. Then we got H, its predecessors is D and F, so after D and after F there comes the H with the cost of 2, that is on the top written here. Then I, its predecessors are E and F, E and F, that is this guy, so they end up into the I. Okay, having the cost 4. Now 2 are left, that is J and K. Let me move this around. One second, I need to grab it some way. Okay. Now I need J and K. After I have drawn out I. Now J has the predecessors H and I, so H and I, then it is, the cost is 10. Activity on node, we're writing 10 here. And then K, its predecessors are G and J, so G and J. Okay, so they move on to here, that's a K, and then it goes to the end, which has cost of 0. So end has a cost of 0 and start has a cost of 0, and this is my network diagram overall. One second, let me delete this now. Now this is my network diagram. Now I have drawn the network diagram. I have got the costs on it. I have got the precedence relationship in with it, that who is after what. That is my relationship. That D comes after A is finished and all that. So I have drawn a network diagram using that information in a table. Now I need to find the critical path. For that, I need to calculate the earliest start time, the latest start time, earliest finish time, the latest finish time. The earliest finish and latest finish, that will come in a second pass, that's a backward pass. The earliest start and latest start, that will come the forward pass, okay? And then I need a total slack and free slack. We'll talk about all of these one by one. So we're gonna have 4 boxes on each and every node now and calculating the values, okay? So here I am calculating the values, that is the earliest start and latest start, because first I will calculate the two, earliest start and latest start. So we need to know how we are calculating these things, earliest start and latest start, which comes by forward pass. In a forward pass, that means in the forward pass what you do is you start from the start and you go forward, either this way, whatever way, but you are going forward up to the end, okay? Whatever the way you choose, you go from the start node up to the end in a forward direction. That's called forward pass. Using that, I will use the ES, the earliest start, and the earliest finish, ES and EF. So I have got a box here. So this one is for the ES and this one is for the EF, earliest finish, earliest start, earliest finish. That means if I'm talking of this node, for example, when is this gonna start? Okay, and EF will be when this gonna finish. So let us talk about using the formulas, right? So what I was trying to do is Control V, yeah. So step 1 is make a forward pass for the network as follows. For each activity I, for example, I'm talking of A right now, the activity I begins at the start node. Then you need to compute what? Earliest start time. So how we calculate the earliest start time, okay? So this is going to be my earliest start time. The first box, this one is going to be earliest start time. So that means when technically it will start, the activity I will start. So for the first activity, this is going to be 0. For the start, it is going to be 0. Okay, its earliest finish time is also 0. So earliest start time is 0, earliest finish time is 0 for this one. Now I am talking of my I is this one, the A, the node A, okay, or the activity A, because I am putting the activity on node, okay? This is the activity on node. Otherwise, the A stays on the arrow if I don't use the activity on node. But if I use the activity on node, then I am putting the activity on the node and the time on it. So you should put this thing in the note that we are using activity on node. Otherwise, your activity is the arrow. Okay, put the A there and put the whatever the cost is there only. Okay, but to make it easy, we use the activity on node approach. So you should write in exam that we are using the activity on node approach. Okay, so now here this is the A, activity A on the node. Okay, otherwise that was an event, but activity on node, we have put the activity on the node. So for this now, if I want to calculate the earliest start time ES, okay, that is the maximum of the earliest finish times of all the activities immediately preceding activity I. That means this activity, whatever the preceding activities are, this time it's only having one arrow. Maybe it has some other arrows also coming up, maybe some other activity coming up also on it. So we have to see what is the maximum of the finish times of all of these. I have explained it in the last video also, because I can start A only when it's all the predecessors are finished. So I have to see who will take longer to finish. Maybe this is taking longer, 9. So this was 7 only, this is 4 only. So I have to take 9 then, the longest one, the longest path. So I have to see among the activities which are incident on the activity A, or which are predecessors of the activity A, which one is the maximum. So I have to choose the maximum of the earliest finish times of all the activities which are preceding to the activity I'm talking right now. Okay, but in our this case, our earliest start time, we have only one node on it. So on A, we have only one node coming to it, so there is no contention of the maximum. It will be only the whatever the finish time of this is. Its start time will be what is the finish time. So earliest finish time, this is earliest start time, earliest finish time. Whatever is the earliest finish time, that is going to be the earliest start time of this activity. So what will be the earliest finish time, okay, of activity A? So that will be earliest start time, whatever the earliest start time is, plus whatever the time requirement is, the completion time of this activity is, that is 30. For A it is 30. So I have to do earliest start time, that is 0, plus whatever the time is 30, that is 30 plus 0 is 30. So I got the 30 as the earliest finish time of this activity, right? Right. Let me get it a little smaller. Now we know this thing, right? What is, so we can calculate for the other nodes now. So what about the B? Its cost is time is 15. So what will be the earliest start time? Earliest start time will be, what is the earliest finish time of it? So this will be 0. For this also, what will be the earliest start time? Earliest start time will be what is the earliest finish time of the previous, because the previous is start only, finish time is 0, so earliest start time is 0. So earliest start time for all of them, all of the three nodes which are the beginning nodes, is going to be 0. Okay, but for the finish time, I have to use the start, the finish. What is the earliest finish time? Earliest finish time will be earliest start time plus the time. So earliest start time is 0, 0 plus 15 is 15. For this guy, it is 0, 0 plus 25 is 25. So it's very simple, right? So if I was just explaining, but if when you learn it, you can do it very quickly. For all of the starting nodes, the start time is going to be 0, and for the finish time, it's going to be whatever that is, 15, 15. So 30, 30, 25, 25, right? So after that, I will go to this level now, D, E, and F. So what is gonna be the start time of this node? The start time of this node is gonna be the finish time of this node. So when सिंपली जब ये फिनिश होगा तभी ये स्टार्ट होगा ना. लेकिन हाँ, अगर डायग्राम में 2-3 इसके ऊपर नोड्स आ रहे हैं तो उन सब में जो बड़ा होगा वो होगा इसका, क्योंकि जब वो खत्म होंगे तब ये शुरू होगा. ठीक है ना, वेरी सिंपल. सो टेक्निकली फॉर डी, ई एंड एफ, the start time will be the finish time of this, because when this finishes, when this has finished, this will start. So start time, early start time will be whatever the early finish time is. So early start time of this is 25, because we have to see it why it is 25. Oh yes, it's coming from here, not coming from here, sorry. So earliest start time of this is, what is the earliest finish time of it? That's 25. For F, earliest start time will be, what is the earliest finish time of B? That is 15. So it is 15 here. Now what will be the finish time? Finish time will be whatever the start time is. I'm talking of this guy, this line now. Whatever the start time is, what is the earliest finish time? Whatever the earliest start time is plus time. So time is 3, 30 plus 3 is 33. For this guy, 25 plus 7. For this guy, this is 15 plus 1, that is going to be 16. Okay, same way we calculate for the next one. So I typically don't need this now, I will delete this. Okay, now for the G, what will be, because only one node is incident, so whatever the finish time is, that is going to be the start time of it. So for this guy also, whatever the finish time is here, that is 16, that is going to be this. Okay, now there is a contention. Yes, there is contention. See, for this G, because I told you start time is the maximum of the earliest finish times of all the incident activities or all the predecessors. So now G has two predecessors, D and F. It has 16 as a finish time and this one has 33 as a finish time. So that means which is bigger? 33 is greater than 16. Therefore G has the start time as 33, not 16, because 16 is smaller. Why? Because G can start only when F and D finishes. So F finishes at 16 time, but D finishes at 33 time. So it cannot start at 16. It has to start at 33 when the D finishes. And at that time, both of them has finished. So I can go for this G. Okay. For H also, there are two incidents. So D, which has finish time of 33, and F is finish time of 16. So I will take 33, which is bigger, maximum of the two. So 33 is going to be the start time of this H. And what about I? It is two incident. This one is 32 and 16. So bigger is 32. So 32 is going to be the start time of this node, right? So what is going to be the finish time? What is going to be the finish time? Finish time is simply the start time plus the time. So that is 33 plus 5, 33 plus 2, that is 35. Now here 32 plus 4, that is going to be 36. Same way for this node K. What is going to be, because it's only one node incident, so whatever is the finishing time, okay, but no, two nodes are incident, sorry, again two nodes are incident, so bigger of the two will be here. The finish time is 38. For this one, finish time is 46. So 46 bigger, so it's gonna be 46 start time. Early start time will be 46. And what will be the early finish time? 46 plus 8, that is 54. Okay, now we got the K. Same way, if we talk about the 10, for example, I have not calculated first. I should have calculated first the 10 because it's going here. So whatever is the this is 35 and this is 36. 36 should be the start time of it, because the bigger of the finishing time of the previous nodes, the predecessors, has to be there. And 36 plus 10, 46 is going to be here. Now after that we go to the end. Okay, so end node will have the earliest start time and earliest finish time. The earliest start time will be same. What is the earliest finish time? Okay, and that is it takes 0 cost. So 54 plus 0 is 54 only. So for the end node, we have the total, whatever the total cost is, that's 54 will be a start time, and 54 will be the final time. That means totally 54 is the time, completion time of this whole project. Now I have calculated the forward pass. In the forward pass, in the forward pass, we calculated the earliest start time and earliest finish time, these two guys. But now we need to calculate, these two guys are done. Okay, that were the two upper boxes, earliest start time and earliest finish times. Now we need the bottom two boxes. Okay, the bottom two boxes is the latest start time and latest finish time. So how we calculate that? Going from backwards, from back to forward. Now I go reverse direction. In the forward pass, I went in this direction. In the backward pass, I will go from end to start. And in the forward pass, we were seeing the maximum of the two, and here I will see the minimum of the two. Now in a step 2, big say we're going for the backward pass. So in backward pass, we calculate two things, that is my latest finish time and latest start time. For the end node, whatever the project completion time is, that is whatever the project completion time is, that is gonna be my latest finish time. So this is my latest finish time, and this is the latest start time. Okay, so latest finish time will be same as that of project completion time, that is 54. We have calculated that. And how we get the latest this latest start time, that is latest finish time minus the time. So is 54 minus 0, that's going to be 54. If you could see here, we are talking about latest finish time. That is going to be the minimum of the latest start time beginning at node J. Whatever the minimum is, the latest start time is at the beginning of that node. Okay, that is going to be the latest finish time, and the latest start time will be simply latest finish time minus time. Okay, let me delete this and we will calculate our things. This will be clear actually when we do it. Now we have seen the latest finish time is 54. 54 minus 0, that is 54 only. So latest start time is this thing. For this guy, because only we have one choice, we don't have a couple of choices, or here we see for F there are 3 choices to choose from. When there is a single choice to see from, the latest finish time will be same as previous latest start time. So it is 54, is going to be 54 here. This is also single C. What will be the latest first start time for this? Latest start time will be 54 minus 8, that is 46. So this latest start time will become latest finish time of node G. Now look here, the 46, this is 46. And what will be the latest start time? Latest start time will be 46 minus 5. 46 minus 5, that is 41. Okay, same as this guy. Its latest finish time will be same as latest start time, that is 46. And how we get the its latest start time, that is 46 minus 10, that is 36. Now I, same way, it is 36, so latest finish time will be 36. So latest finish time will be same as latest start time of the next node. Okay, because we are coming from the reverse now. Basically j is the next to I is the predecessor to the j, right? But because we are coming from j to I now, that is what we are talking. J's latest start time will be the latest finish time of it if it is only one, if it is only one node, if there is only one choice. And what will be, how we calculate the 32, that is 36 minus 4. So latest start time will be whatever the latest finish time is minus the time. So 36 minus 4, that is 32, right? Same is for this. Whatever is its latest start time, that is going to be its latest finish time, and 36 minus 2, 34 will be the latest start time of it. Now if we talk about the F, E and D, if we talk about D first, okay, now it has two choices, this and this. Now it will see the minimum, because I want to see what is the latest finish time. I will see what is the minimum latest start time of the nodes where from it's coming, okay, G and H. I am seeing it is 34 and it is 41, which is lesser. In the forward pass we are seeing the greater, here we see the minimum, not maximum. So 34 is lesser, so it is going to be 34. Then 34 minus 3, that is 31, will be the latest start time of the D. Now for E there are two choices, either there is single choice only for E, right? So whatever is the start time of it, that is going to be its finish time. That minus 7 will be its latest start time, 25. Now if we talk about the F, it has three choices, this one, and this one. For this I want to see the latest finish time of it. Now I am seeing here the latest start time is 41, for it is 34, I guess, yes, it is 32, so which is minimum out of 41, 34 and 32. 32 is minimum, so I choose 32 to be the latest finish time of it. How I calculated the start time? 32 minus 1, that is 31. Okay, let me clear the clutter. So we are done with this line. Now there is choice of A, B and C. Now they are simple single. So whatever is here as a latest start time, that's going to be the latest finish time of it. 31 minus 30, that is 1. It is will be latest start time of it. Same is with this guy, because only one choice, so it is 31, that will stay here. 31 minus 15, that is 16, that is going to be here. Same is for this, it has come from here. 25 is the latest start time, that is going to be latest finish time of it. And 25 minus 25, that is 0, is going to be latest start time of it. Okay, then going back to it, because this is the start, so whatever is the latest finish time, that is 0, that is going to be because it has now three choices to come from. So which one is minimum? Is 1 minimum, is 16 minimum, or is 0? So 0 is minimum, so 0 is going to be the latest start time, finish time of it. And 0 minus 0, that is 0, is going to be latest start time. So I am done with the calculating all the four, latest earliest start and earliest finish that we did with the forward pass, and latest start and latest finish that we did using the backward pass. Okay, now after calculating the early start, early finish, late start, late finish, now it's time to calculate total slack and free slack. Now total slack is also called as total float, and free slack is also called as free float. So some books write free float, some write the free slack. So you can use the word slack or float interchangeably. Okay, where is the pen? So you can use your total slack or float, free slack or free float. You can use free float or you can say total slack. So what is this total slack and total the free slack? What is this? We will now see. Now what is the total float or total slack? Okay, that is we usually sometimes call it as float only. It is how long an activity can be delayed without delaying the project. That means you want to delay this activity, for example, without delaying the project. Let me get it a little down. So you have for example, this activity, how much you can delay this activity without delaying a project. That's what's called as a total slack or total float. Okay. And when we try to find actually the critical path, wherein I will try to find the critical nodes, the total slack should be 0. That is, I should not be delaying my activity. So where there is a 0, that means I'm not delaying anything. I will choose that only as my critical path. We'll see that shortly. It's also called as a total slack, like I told you. So how we calculate it? We subtract the uh, the late start or early start. Actually, we have used this term. We can use the late finish and early finish, or latest finish, as in our case, latest finish minus early finish. That means this is the latest finish, this is the earliest finish. Subtract the two. 1 minus 0, that is 1. 31 minus 30, that is 1. That is my total slack. 41 minus 33, that is 8. 46 minus 46, that is 0. 54 minus 54, that is 0. So if I calculate all of this, you see I am, let me now delete this. I am actually doing what? I am dividing the subtracting the earliest finish with the earliest start. 16 minus 0, so 16. 25 minus 25, that is 0. 34 minus 33, 1, and so on. 36, 36, 0. 32 minus 32, 0. 31 minus 15, 16. 0 minus 0, that is 0. Again, for 0 minus 0, that is 0. That is, you have to subtract earliest finish minus earliest start to get the total slack. Okay. Now next is the free slack. Now our free float, or we also call it as the free slack. Okay. What is, how we calculate that? So what is this? Firstly, this is how long an activity can be delayed without delaying the early start of its successor activity. If I'm talking of A, so how much I can delay this A so that I cannot, without delaying the early start of D. So how much I can delay this without making the delay for the next activity. This is what's called as the free float or free slack. So how we calculate that? We subtract early start of next activity. So this is the early start of next activity if I'm talking of A, minus your early finish. So the activity I'm talking about, it's early finish. Okay, subtract that from the early start of next activity. That's 30 minus 30, 0. So let's try to calculate these things now. So we have here 30 minus 30, that is 0. For this guy, this is 33 minus 33, that is 0. For this guy, it is 46 minus 38, that is 8. For this guy, it is gonna be 54 minus 54, 0. And for the last one, it's gonna be 0 itself. For the beginning one, it's gonna be itself. You can directly put that. For this one, for example, the 15 is 25 minus 15. That is gonna be the, 1 second. No, it actually comes from here, not here. That's a confusion. Arrow is here. So it's it is 15 here and a 15 here. So minus them to get 0. For this guy, it is 32 here and 32 here. That is 0. For this guy, it is 32 minus 16. That is gonna be 16. And for this guy, it is gonna be 36 minus 36, 0. For this guy, it's gonna be 36 minus 35, that is gonna be 1. Okay, and for this guy, it's gonna be, we have done it actually, and we have done it all. So we calculated the total slack and total float now, or total float, I should say, and also the free slack or free float. Now the next step is to find the critical path. So how I find the critical path is I will try to see the nodes which have the total slack or total float as 0. So I'm starting here, I go here, total slack is 1, so I cannot go here. So here total slack is 16, I cannot go here. For this one, total slack is 0, so I choose it, either use the double arrow or bold out or use double arrows. And from here, total slack is 0, I can go here, put up double arrows. From here, total slack is 0, so I can go here, use double arrows to see my critical path. This is having total slack 0, so double arrow, or I can use the bold line. Okay, and from here I can go here, total slack is 0, so put up a double arrow, and that's it. So this path is going to be my critical path, as you could see in the next slide. So this, the orange line, which could be done by either with the double arrow or the bolding up, making it, if you have the line, you can make it bold like this, or simply you can use the double arrows to show the critical path like this. Okay, use a proper line like this and like this. So this is going to be my critical path. So what is the critical path of our project? That is C, then E, then I, then J, and K. So this is going to be my critical path of the project. So this is the objective of the CPM, to find the critical path. So what is the critical path all about? It is the shortest duration of the project. If you see this example, and you will see this is going to be the shortest duration of the project. So I will be having these on my what's called critical events. So the critical events will be these nodes only, which I have seen here, and the totality is a critical path, which gives the shortest duration of the project. Okay, that's all for today, and this is the end of the CPM. Now next we will do the PERT. So see you next time. Until then, masalama.